I've been teaching math for a very long time, and most of those years I've taught Algebra 1. I've gotten pretty used to students asking me lots of questions like, why do we have to learn this? And when am I ever going to use this? And what is the purpose of this? And even sometimes, did you mean to torture me? And I get a lot of these questions, especially in this lesson about the properties of equality. We learn about math because the world is full of rules. The world has rules about laws and things that keep us safe and organized living in our society. When you're learning how to drive, you need to know all of the rules of the road. Someday, maybe you'd like to build something or improve your home, or maybe you're assembling an item that you just bought from IKEA. And trust me, you need amazing skills to build anything from IKEA. You need to be able to follow the rules of the world, and math is also full of rules. Math can help you learn how to work through steps in a non specific manner so that you're more prepared for tasks you may be faced with in the real world. For 2.2, we're going to explore the properties of equality. I'm actually going to show you where they come from and why they are real properties to begin with. We've got a very short vocabulary list, so go ahead and read through those quickly. But let's get to our first definition right away about two expressions. Two expressions are equivalent if they have the same outcome. So remember, the word equivalent comes from the word equal. So equivalent just means that they're equal. In this example, we want to simplify the expressions and match the ones on the left with their equivalent expression on the right. Uh, so let's go ahead and work through these expressions to see what they are equal to. We're going to start with -5 plus 3, and that is going to equal -2. And if it helps you, you can go ahead and grab a calculator here if you need to work some of these out. 12 times 5 is going to equal 60. And this one, don't forget your order of operations. 10 minus 3 is 7, and then 7 times 7 is 49. On this one here, um, parentheses first, 8 minus 5 is 3, 3 plus 6, or 6 plus 3 would be 9, and then parentheses first, 5 times 2 is 10, -3 times 10 is -30. Okay, I'm going to give you guys a moment to do the ones on the right column on your own, and you can check your answers with me. I'm not sure if you noticed this, but remember we were looking for that word equivalent expressions. If you look right here, this -5 plus 3 equals -2. And down here, 3 minus 5 equals -2. So those are equivalent expressions. We can actually write those out, that -5 plus 3 has to equal 3 minus 5 since they both equal -2. You're probably wondering if I would ever use some colors in this video, and I am right here. So let's take a look at this one, that's 60, and we've got another equivalent expression that's also 60. That means that 12 times 5 has to equal 5 times 12. That basically these first two rules, and these are our first two properties of equality, what they're saying is that if you have addition or multiplication, that the order that you add or subtract the numbers in does not matter. The next one is equal to 49, so 7 times 10 minus 3, and we've got a 49 here, so these two must be equivalent. So this, if we take a look here, we've got 7 times 10 minus 3 is equal to 7 times 10 minus 7 times 3. Okay, so this is a really unique rule that it's actually a very, very useful rule in algebra. Next, we've got this that's equal to 9, so 6 plus 8 minus 5, and then 6 plus 8 minus 5 is also equal to 9. And last, we've got this one that's equal to negative 30, and it's equivalent over here. So we've got negative 3 times. One thing, don't forget that when you have a number that's just touching a parenthesis, that implies multiplication, even when you don't see it. So we've got negative 3 times 5 times 2, and then we've got negative 3 times 5 times 2. So that's just a little bit different. These last two rules, these ones are saying that as long as you have the same type of operation, so here addition and subtraction, you don't change the order of the numbers, but you can change the placement of the grouping symbols, in this case parentheses. Same thing with multiplication. Negative 3 times 5 times 2, negative 3 times 5 times 2. Notice the only thing that changed were the parentheses. So based on all of those patterns above, mathematicians hundreds and thousands of years ago, okay, maybe hundreds, created properties of equality, which allow us to make changes to algebraic expressions, making equivalent expressions, and still having the same values. So we're going to explore that more in the next two videos.